So the question that I got right before I started recording, oh, I better start the Zoom. Sorry, I'm never quite prepared, but I have to, my schedule's so tight. I come here right from class, and I can't get my computer ready while in class.
Your Greek class?
It's my Greek class, right?
Ah.
Which we don't use the computers in the Greek class, and so I don't have it out.
They didn't have computers in ancient Greek times?
Oh, sure they did. We just don't use them. We just, yeah.
And Greeks were smart, man.
Though they were. Okay.
Recording in progress.
So the question I was asked right before we started was about, really, how hard is this project? And I said, well, it's not that hard. It can be a lot of work. And the reason I think it's not that hard is because I've done similar projects a number of times. The very first time I did it, I did find it hard, but it's also true the first time I did it, I didn't really buy into the stuff that you learn in Digital Logic 2. I thought, I'm a good programmer. I've been programming lots of things. I know how to program. I can just sit down and program this, and I can condense these things here and these things here. And then it just had so many errors and took forever to fix. And over the years, what I've discovered is that it really, really, really just works best if you just kind of believe that, yeah, I'm supposed to do a finite state machine. And if you do a finite state machine and you set it up right, then the coding is really pretty easy. And so the finite state machine, what it gives you is you'll know for every state exactly what other state you would go to based on your inputs, and you know exactly what your output should be. And so given that there's not really a lot of coding to do, the work is done in the preparation. And so I said, if you're going to be here, make sure that you have your state diagram done. If you don't have your state diagram done, I will talk about it a little bit. It's what's in the video, and it's what we did last week. If the way we did it, the way I strongly recommend that you do it, is that you not have any programming outside of your finite state machine. Even like now when I was doing it, I was thinking, oh, well, I can just put this single little if in here, and then I can condense these two states. There's no need for it. You can just copy and paste. And if you just have just your states, it should work out okay. So let's talk about this. Let's have this be a group thing. I know that at least one of you already has a state diagram, and some of you might from watching the video, and I'll pretend like you all have. And so in that case, maybe we can all talk together. Let's get, I like having group input because we can adjust things to make it the way yours is going to be. What kind of states do you think we need to have, and what do you think they should do?
First, second, and third floor for sure.
Yeah, first, second, and third for sure.
You need an open and close.
So we definitely need more. So we definitely need a close. So we definitely need a closed state for each floor.
And
door to be open for a little bit longer.
Yeah, we do. And so I think it's easiest to do that with another state. Like I said, to start off with, you could do it with programming. You could say, all right, I'm going to stay in this state for another cycle. I think it's easier just to have another state.
Yeah.
And so you have the first state is the state where you, when you arrive. I think in previous years I called it first and second. I think this year I'm calling it, arrive. So you arrive, and you need the door to stay open for at least another cycle. So I was thinking the arrive state is your first time for having the door open, and then this other state is any other time you have it open. And the reason those need to be different states is because you can't go from this state to another floor because the door has to stay open. So on the next clock cycle, you have to be on the same floor. But if the door's open, once you've gone to the next state, this state can go to other floors. And so it's fine if you're in this state to come back to this state if you need to for some reason, because once you're in this state, you can go to other floors. But if you're in this first state, you have to get to the second state before you can go anywhere else. And so this at least this is the way I see it. And so how many switches do y'all have? How many inputs do you have? You have 4 switches. You also have a clock, but that's not going to be a switch. In mine, I put an extra switch for a reset. I'm sure it's fine if you wanted to put extra things in for debugging that you just don't have to demo if you don't want to. So in my program, I have an extra state for a reset. And we looked them up, and on the board, they are like in this order with the hold the door open button. I think there was an empty space in between on the switches. Like this was a switch that we weren't currently using. I may use that for my reset, but that was the hold the door open. And so another tip, so this is something that, this is new. So I recommend that you have your inputs be a single variable, and that's going to save you from having to have lots of, if switch 1 and if switch 2 and if switch 3. So I recommend that you have one variable. I very lazily called it SW because that's the variable for the switches in the constraints. So I have input 30 SW. And what that allows me to do is to treat all my switches as one variable. So I can talk about my switches all together as equaling 4B1011. And so what would that correspond to if my switches are set up like with this is first floor, second floor, third floor, and my door hold open? What would 1011 mean?
It's just binary for 6. Or no.
It's binary for 8, 10, 11. But, yeah. It just means that this switch is on, and this switch is on, and this switch is on, and those are off.
Oh.
Yeah.
My goodness.
And
I was
by
so,
you don't have to do it this way, and even if you do it this way, you can always refer to switch 3 is the hold, and switch 0 is floor 1, and you can always refer to them individually, but this way I can refer to them all together. And if I have a situation like, let's say I'm on my first floor and the door is open, and someone presses the hold open button. Does it matter what other switches are pressed with what the next state is, right? And so in that case, I can have something for doing that where the X's stand for don't cares. And that way I can get rid of a bunch of combinations of switches all at once. Because the reason why at first I wanted to do extra programming rather than states is because I thought, with 4 different switches, that means there's 16 different possibilities. That means not only do I have 11 or 12 or however many states, with each state I'm going to have a case with 16 different things, and that's going to go on forever. But you don't have to, because like this combines 8 all into one. And so that makes the programming a little easier. Now, in order to do that, when you use your case statement, you actually use case Z. And case Z handles those don't cares better. I just know that from trial and error, that if you don't use case Z, the don't cares don't work as well. Okay, so let's take a look at those of you who were at my session. That's not it. There it is. Okay, so this is based on the way we talked about it in our group, how our state diagram looked. And so while it does look a bit intimidating, what you want to do is, and yours does not have to be like this, you don't have, and it shouldn't be, you want to think about it yourself. You might have different ideas than we did. For instance, we said if you go from floor 1 to floor 3, the instructions say you can go 1 floor every clock cycle. The first few times I did this project, I didn't. I said, if you're on floor 1 and floor switch for floor 3 is set, you just go to floor 3 on the next clock cycle. And that seemed to work. Everybody who did it like that did fine, except for one person who the TA said that he didn't stop at floor 2. But, so now I do want to make sure that I go to floor 2. So I have, if you're on floor 1 and you have 0, 1, 0, 0 as your switches, what does that correspond to? To go to floor 3, because this first one is your hold. This is 3, this is 2, this is 1. So I said you'd go to floor 2 first, and from floor 2 you would go to floor 3. Now you could, and this would be perfectly fine, say that in whatever state you make this, so this is your floor 2 on your way up, you just say you don't care. No matter what you've got, if you're in this state, you're going to floor 3. And that would be fine. There's nothing wrong with that. We decided when we were working on it that if you were in this situation and it goes to floor 2, if you change your mind and decide you want to get off at floor 2, you can do that. So we had more states here than just that. So you can have different states, but what you want to do is to make sure that you've accounted for everything. So we're going to pick a state right now, and we're going to make sure that we know how to do this, and then we're going to talk about how to code. So somebody pick a state that you would have in your state diagram. You can only kind of go wrong here, not too wrong.
I'll find a way.
Yeah, anytime I say you can't go wrong, somebody says something and I'm like, okay, all right, I shouldn't have said that. How about I pick floor 2 with the doors closed? Okay, floor 2 with the doors closed. I called that floor 2 rest, because your instruction said you had to have a rest state. All right, so let's think about what our different options are. What should happen if you do nothing? if no switches are set.
Goes back to rest.
You should absolutely go back to rest. So we would think a 0, 0, 0, 0 should be going back to rest. Here's another place where I think you would have some option. The instructions say for the hold button, it says if the door is already open, then the hold button should keep the door open. But we looked at this and said the door's not already open, so that we just said the hold button shouldn't do anything at all, is the way we looked at it. Now, I could very well see, you could say, wait a minute, no, if I'm in that elevator and the door's closed and I press that button, I would expect the door to open, and that would be fine, if that's what you decided. So, however we decide to do it right now is gonna be how we decide it. Okay, so let's say, what do y'all think, well, let's talk about it. What do y'all want to happen if someone presses the hold button?
You'd stay in the rest state.
If nothing else is pressed.
Mm-hmm.
Okay, so you're saying this could be don't care
Yeah.
0, 0, 0.
Yeah.
Okay, I like that. All right,
It's less complicated like that.
okay. Well, we are going to have to, but we have to account for every state is the thing that, so right now we've accounted for 2,
Okay.
and there's 16. So now let's think about what happens if the next hard one that you have to make a decision on is what happens with the floor 2 button.
Nothing. Rest it.
So you're sitting in there in the elevator, the door's closed, and you press 2, it's just,
It's their fault
You're
for
stuck?
hiring a sophomore.
all right,
So have the doors already opened or not?
not,
So we just arrived at floor 2 and nothing has happened.
well, you could have done that no, that would not happen. You would have, you could have gotten in the elevator on floor 2 and not pressed any button. So that
Okay.
while the door was open, elevator's here, I'm getting in.
Okay, because I was thinking like you got in the elevator, you got up to floor 2, the doors open, and then they close, and that'd be your rest state.
That could be it too. So the reason you would be in this state would be if you were in the elevator is you got to floor 2, the doors open, they stayed open, you were busy getting your backpack, doing a text, and the doors close.
Okay.
Or you were on floor 2 and you were outside waiting for the elevator, doors open, and you get in, and you just sit there. You don't press anything, or you press the hold button. Nothing happens if you keep pressing it and nothing's happening. That's the hold button because that's the way we set it here. That's not the way we decided. No, yeah, it is the way we decided. Okay, so
If we want to make it like functional,
well, we don't have to. I don't think the TA is going to ask any of these weird things
No.
personally. But you still have to decide. You still have to program them in, because if you don't program them in, Viveda will say, wait, you have some stuff unaccounted for. Or the default state that you set might cause some problems. So y'all want floor 2 to do nothing, so we'll put an X right there too. That's fine. There's nothing wrong with that. That's your call.
wait,
Okay.
Wait, did you guys do
No,
it
that's
too?
not what we did.
What did-
That's not what we did. No.
Yeah,
Let's
I'll
do
do
it.
it for your
Let's
video.
do it.
I like doing it with the video.
Oh, we like the video way because that way, yeah. I thought,
It
yeah.
makes more sense because
Okay.
Okay,
So
what she's saying exactly, you're basically trapped inside.
yeah,
Yeah.
and I don't want
You
Yeah.
don't want to not
So
be able
there'll
to.
be doors
Right.
at 0, 0.
so we had don't care, and
Don't care no matter what.
don't care.
They're just gonna die in there.
That no, and so we said if we have don't care, floor 2 don't care, we wanted the doors to open. We wanted to be able to get
So
out.
it'll go back to okay.
Yeah,
It'll go back to the open state.
yeah.
Is that what you did?
Yeah.
Yeah.
So that's the way we did. That's the way we did it.
That sounds good.
I would button do it for you.
Okay. Now we have to decide what to do. So how many states did we account for right there?
3.
Let's see. We accounted for all of those don't cares, let's see, there must be a total of 2 to the 4. There must be 16, and this gets us 8. So if you count, yeah,
What?
because we have 1 and 0 for this, 1 and
I
0 for
see.
this, and 1 and 0 for that. So this one gave us 8, this one gave us 2. But we are going to have to check and make sure we don't have any overlaps. We don't want to have like something that could apply to both states. Like for instance, if I did this, if I made one, I said x 0, x 0, and I wanted that to go somewhere, that would be a problem, because that one and that one, if I put in 1 0 0 0, which of those two would it choose? It matches both of those patterns. So you have to make sure that all of your patterns don't overlap. You can't have a pattern that overlaps. Okay, so now we need to talk about what happens with the floor 1 and floor 3. So let's say we've put in floor 1 and we don't put in floor 3.
I would say it wouldn't matter if, oh, yeah, no, it does.
Now, we have to say no on floor 2, because if I put a 1 in floor 2, then it's going to overlap with this pattern. For all of my other patterns, I have to have a 0 in floor 2. For the hold, it doesn't really matter what I put in for the hold, because we've said the hold does this, but if I want to make sure I account for all 16 states, I'll put a don't care right there. Otherwise, I'd have to have a 1 0 0 1 and a 0 0 0 1.
Would it be okay if you made it to where you press, say, the 3rd floor? It doesn't matter if you press the 2nd or the 1st. It just goes to the 3rd no matter what.
Yes, but then we'd have to change this one, because this one is saying that if floor 2 is pressed, it doesn't matter what the others are.
Okay.
So if you want to change it to make it go to the 3rd floor no matter what, we'll do that. I'll show you how to do that after.
Let's keep it on track like this, where I don't want to confuse myself.
Okay.
So I was just saying what.
Yeah, so we are okay, so let's decide right now. I honestly don't remember how we decided, and I didn't pay any attention to it when I wrote my code, because I was not specifically writing it for how the video went. Just saying that. You do have to decide what to do if 1 and 3 are both pressed. Which one are you going to go to? And you just have to decide, because there's no.
One was pressed first.
You don't have any way of knowing that. The board doesn't keep track.
Okay.
It's just going to, at the clock edge, it's going to look and see, are both switches on? Y'all probably would want to know how, well, you probably want to know how it is in my code, but I haven't programmed that part yet.
How to do that? Like, what would?
Okay, so well, that's what I'm getting to. That's what I'm getting to. So if we did, let's see what we did. We did, 1 had priority. We did 1 had priority.
Oh, okay.
Okay, so if 1 has priority, then we're saying we don't care what this one is, because if 1 is pressed, we're going to go to 1. So we had x 0 1 goes to floor 1, and which of floor 1 states should it go to? Arrive. How many states does this account for? XX01. That accounts for 4. So now I have 8 and 2 and 4. That's 14.
You have to do the 3rd.
We've got to do the 3rd floor. So the 3rd floor would be
I think
X
1 0
0 0, exactly.
Yeah.
X1 0 0. Okay, we have to have those zeros in there, and that would go to 3rd floor arrive. And then if you watched the video, what you want to do every time you've done this for a floor, you want to make sure not only have you accounted for all 16 states, so you want to think about what the different states are. So it's all of those plus the same thing but with a 1 in front. Is there an option for every one of those? So just, look at them at random. So like 0, 1, 1, 0. If I had 0, 1, 1, 0, what am I going to do?
Open.
That one is going to be open. Exactly. So you want to make sure you have every state. You also want to make sure that you don't have any states that could fall into 2 categories. Because if they fall into 2 categories, you're going to be in trouble. So that's how you're going to do your state diagram. Then when you go to do your code, what's funny is when people come to test their projects and they have their code, I see like a lot of times it's like almost exactly like mine, but just, the variable names are changed a little bit. But try to do it on your own without just copying. And it is fine, absolutely fine to have your own ideas. Okay, so what are you going to need? You're going to need the 7-segment display. If you're as lazy as me, you can call your things these because that has the same names as the constraints, if I recall correctly. I haven't done my constraints yet. Let's go ahead and do the constraints because everybody will have constraints. Okay, so we have the 7-segment display that I always do as an 8-segment display because I include the decimal point. So constraints. So we'll have the 7-segment display. I'll uncomment that. And I call the decimal point. You don't have to put this one in. It bothers me because it comes on my board. Call it seg7. And also to use the 7-segment display, you also have to have this AN. That tells you which of the 4 displays you're going to use. So you have to have that one as well.
Say that one more time. Which of the what?
On the board, there's 4 places where you can put a 7-segment display.
Oh, okay.
This one tells you which of these you're going to be putting it on. And it is active low, meaning you put a 1 in the ones you're not using and a 0 in the one you're using. And your handout told you which switches to use, and I believe they were. Do you remember what they were, anyone?
They were 1, 2, 3, and 5.
1, 2, 3, and 5. And I'm going to include 0 on mine for the reset.
Do we have to have a reset?
I find it helpful for testing. I'm probably also gonna put something else in here for testing that I'll show you when I start talking about it. So you said 1, 2, 3, and 5. So I'm gonna call 0 reset. And then I'll get rid of 4.
Do you have to get rid of the squiggly brackets?
Nope. You can leave them in. What? Okay, it's because I had an extra one up here. There we go. Okay, so there we have the switches. We have to have an LED. Does anyone know which LED we need?
It's
11. Okay, so I am actually going to put in 11 through 15.
No, you just need it for your output.
This is to say whether the door is open or not.
Oh, okay.
Because, like, that's what the 7 segment display will show you what for.
Okay.
Now, I'm going to leave these commented out for right now, but the reason I put in the other 4 is for testing. I'm going to use those to show me what state I'm in. So what I'm going to do in my code is as I'm testing it, I'm going to have, so current state and next state are currently just reg. When I'm testing it, I'm going to have since I'm doing it, I'll go ahead and do it. I have my numbers in the wrong place. So as I'm testing it, I'm going to put current state as an output. And so that way, when I'm looking, I'll be able to see what state it's in and is the output the way it's supposed to be. And then once I'm sure everything is working, I can, if I want to, take that current state out of my list there and take this word output out of here, and then everything is fine. So the only thing that's different is this word right here, output, and the fact that I put it up in here, and then I can use it for testing. And so that's what I'm going to use these other LEDs for. And this one, 11, I just called LED. And since I went ahead and put it in, current state 0.
Is that one current state? Is that, it's an LED, right?
It's an LED, and I'm just gonna be using it while I'm testing it. I'm using this so I can look at the LEDs to see what state I'm in. So
Okay.
I'm gonna take it out when it comes time, when I'm all done. So this is just kind of a debugging thing.
Okay.
So this is not gonna be in the final project. I mean, it doesn't hurt anything to be in the final project. You can put it in, it's certainly not
Yeah,
wrong.
I don't think if I do that, I don't think I would remove it.
Yeah, I honestly have to.
Cause like,
Why would you need to remove it? Yeah,
exactly, I'm like, if it ain't broke, don't fix it.
right.
I definitely won't do.
Okay, so now I have that in there. But the LED is the one you have to have, and the LED shows whether the door is open or not. And all right, so let's see, where was I? Oh, constraints. I was doing constraints. We need to have a clock, and so I'm going to get the same clock we used on our last project. How did Lab 10 go, by the way?
Well,
It was okay, better than most. I did realize that, I mean, I realized this a while ago, but if you use the button as a clock, it sucks because it double clicks whenever you press it once.
Were you at my session for the thing? Because I
She said the
yeah, said use the debounce button.
I've
Debounce?
never been able
What
to
is
get
that?
that little
So it's like-
widget to work.
Oh yeah, no. Every time I tried using that, it never works.
I never.
Never, not a single time, and
I
I've used it
the
every
button
single
clock and it
time.
went fine. Actually, no, I redid it and I used a switch for my clock.
Yes, you use a switch. You might not be putting it in the right place.
Very possible.
Yeah.
We used
Or you might not be
J1.
using the using J11 or
We
whatever it
used
is.
J1.
I'm doing
Oh,
something.
let's see. Is it J1? I don't think it's J1. I think it's J11. Let's see.
Using J1 every time.
I don't know.
And it's
Oh
not
no,
worked-
it's J1. It's
has
J1.
not worked a
It's
single
J1.
time.
Well, but it works when you do something else. It must be either.
Yeah,
Yeah, I don't know what to say
I
about
don't
that.
trust it. I use switches from here on out. If I
Switches work. Nothing wrong with the switch.
But I hope they don't take points off because of that.
Well, the directions do say to use a button, doesn't
Well,
it?
yeah, but honestly.
I don't think that. I don't think that's important.
As long as it does like the right output.
I really like this. I'm sorry that it hasn't been working for you, but I really like this one because the switch you have to go that way and that way. I mean, all that work. Ugh.
Ah, no.
A button, you just gotta press it once. Okay, so I think those are all the constraints that you will need, I think. Did I do the switch? No, I didn't. Did I? Yeah, I did the switch. Yeah, so that should be it. Okay, so let's talk about the code and what you're gonna need in it. So you'll have to have your inputs and your outputs, and like I said, the current state right there as an output is optional. You certainly don't have to have it in there. Your 7-segment display and your AN that controls which of the 7-segment displays you're using need to be output reg. They have to be reg because you're going to do them in an always block. Your LED is going to be a reg. You'll have your input, your switches. I have them 3 to 0. Why do I have them 3 to 0? Why does that match with what I've been doing? And would it match with what you've been doing? Let's,
Basically doing like most significant or like the placement.
right, because that makes this 3, 2, 1, 0, which matches the way that we've been like writing them. So it matches up. And then I put a reset in, which you don't have to have. And then I strongly recommend, you don't have to, but I strongly recommend that you do, rather than assigning the LEDs within the always block where you get the state, I strongly recommend you do the LEDs, the output, the same way we do the next state, and like figure it out in one always block and then assign it in another always block. So I strongly recommend that you have a next output. This is like really a next segment. It's like we don't say what the 7/7 display is at the moment we figure out what we want it to be. We wait until the clock edge to do that. Actually, we don't quite wait until the clock edge. We kind of do. Let me show you the way I'm thinking about it. I haven't actually tried this yet, but so here's the way I'm thinking about it. I have one always block that is based on your current state. In your current state, you have each of your states, and for each state, so this would be a case statement, case, current state, and you'll see it in a minute. And for each state, like floor 1 rest, I'll have a case Z based on my switches that I say what to do for each of the switches. So this part is going to be to set my next state. Then I have a different always block that's also always at current state. But this one, my case is next state. Actually, I probably should put in here, this probably should be current state and next state. Current state and next state. And then my case is next state. And then I have my next state, and then with each next state, I say what the next output is going to be. Why do I have case next state? So let's think about it for a minute. So I'm on, pick a state. What state am I on? What state am I in?
2 close.
2 close. Floor 2 rest. That's where I am. And haven't pressed the clock button. Okay, and so the TA says, all right, now I want you to set switches 3 and 1. Wants to see what you do if you have both 3 and 1 set. And you should be able to say, oh, it's going to go to floor 1 because that's how I programmed it. You know, so you're gonna do that. So you set those switches. Now your code, your always block, will figure out what your next state is going to be, because I actually have this first one at current state, comma, switch. So anytime the current state changes or the switches change. And so the switches changed because I set them. So it'll go through here and it'll go and it'll find it and it'll say, oh, okay, it'll set my next state is going to be floor 3 arrive. And that's what I'll set. My next state is going to be floor 3 arrive.
After, is this before, so you set it to that and then you do 1 clock cycle.
So I haven't done a clock yet.
Haven't done a clock cycle.
Haven't done a clock yet.
When did the next cycle be? When it be floor 1 arrive? Because we.
Oh, yeah. Floor 1 arrive. Floor 1 arrive.
Okay. That makes more sense.
Okay, so it won't actually change any outputs, but next state did change. So since next state changed, my other always block that has always at next state says, oh, my next state changed. I better figure out what my next output is going to be. So then it'll go through and it'll say my next state is floor 1 arrive. All right, well then my segment should be the segment that looks like that, and my LED should be on because the door is going to be open. None of that has actually happened on the board yet, but you're setting that. And then if you say, oh no, never mind, I want my switches to all be off. Okay, so you go and set them to off. And then this always block says, okay, switches changed, they're all off. What am I going to do? Okay, well, I'm going to stay where I am. Well, then your next state just changed. And since your next state just changed, this always block said, hey, my next state changed. I need to figure out what my output's going to be. And then it refigures it out. Nothing has actually happened on the board yet, but all this calculation is going on. You have such faith in me. It's like you're just like, yeah, I don't understand, but I trust you. That's the look I just got.
That's exactly what I was thinking.
Yeah. Okay, and then I have my last always block is always at positive edge of the clock. And that one is where things actually change. That's going to be where you have current state becomes equal to whatever next state was, and what I called seg becomes equal to next output. Now, is this a Moore machine or a Mealy machine?
True.
It's tricky.
More?
It's Moore.
Okay.
Yeah, it's Moore.
I don't even know, like, the names.
I know, I get them all confused too, but
Everyone mixed up.
I know them for a few weeks of the year, and then when I come back next semester, they'll all be gone again.
You know, I feel it from the vibe of it. The vibe of the name.
Uh-huh.
It's like more sounds like it's more simple.
Ah, okay. Well,
Moore's
yeah,
more
Moore's
simple.
more simple. That
Mealy
is just-
the one that's not.
And Mealy, it has a more expansive state table. Yeah.
Wait, hold on. More is the one where the output is with the state, right?
Yes.
Okay.
Yep. And that's what we have here. Even though it appears that we're computing the output based on the current inputs, we're not really. We're defining the output based on what the state is going to be, and so the output goes with the state.
I really don't understand what you're doing with this always next state, current state, why we need to do this, and like what it's doing in the code for us that is useful.
It's how finite state machines are programmed.
It's okay, so I just don't know how to program finite state machines. Huh?
Like it is the clock signal. It's like saying
This is
when you press the clock,
Oh, okay,
you're
right.
going to the next state.
So, oh my gosh. Okay.
That's the main thing, is you have one always block that's short and simple that says, when the clock happens, go to the next state. But you don't want to be computing it here. You want it ready to go when that happens.
Exactly. Okay,
The
that makes
other
sense.
always blocks compute what the next state is. And I find it easier depending on the program. Sometimes you have two other always blocks, one to figure out the next state and one to figure out the output.
So we would do like always at next state, right? Or no? We wouldn't
I do
that
always at next state to figure out the output
of the next state.
of the next state. I do always at current state to figure out what the next state is going to be. So in the parentheses are whenever anything in these parentheses change, run this code.
Okay.
Okay, so whenever my current state changes, I'm at a new state. Well, I'll need to figure out what my next state is. So if I go from floor 1 to floor 3, my current state has changed. I need to know what my next state is going to be. The other thing that might affect what my next state is going to be are the switches. So whenever either of those things change, compute what my next state is going to be. Once I know what my next state is going to be, that's time to figure out what the output is going to be that goes with that state. So that's why I have a different always block that's at next state, that anytime you figure out what the next state is going to be, figure out what the output's going to be.
Yeah, I think I just need to look at an example to be more than, even though I should know. this.
Maybe what I'll do, if I have time, I can't say that I will, I'm already behind in my classes, I'll do like a simple example complete with all of the code, because I'm not going to do all of the code. And anybody who's watching this who comes, they won't watch this part, because the people who do this don't watch all the way through. So the people who come to me, it's like, I think I have it all done, and I sit down and I look and they have exactly what I have, with all the parts missing that I didn't put in the video. That means that all they did was go to my video and go to the part, that has the code on it and copied right was on there, and didn't listen to anything I said. And that will make me grumpy. But those people won't hear me say this, so, that's fine. All right, so
Skipping through it, and then they just so happen to.
it's hilarious when I look at the analytics from YouTube, because it shows you like how many people are watching, and there's like a spike. And when I go to that part, if you get like exactly there, then it's like you can freeze frame like on my code, and it's kind of funny. But let's see. So what else are we going to need? Okay, so I put in parameters. So the parameters, I named each floor. In the past, I did it just by binary numbers, because I thought, well, I'm smart enough, I can do that. I'm not. It's just, it's better to have the names so that make sure you go to the right place.
This is good enough for me. Like, this is what I needed to look at to understand what was going on. So like the next state. Wait, you didn't even code it.
I haven't gotten there yet.
Okay, but that next output is the parameters.
No.
No. Okay.
No,
I'm
you
just-
don't know what you're talking about. So.
I don't know what I'm talking
Yeah.
about. Oh,
Okay.
Well, the next
terrible.
Now, okay, so the parameters, those are just naming. Those are naming my states. That's all it is, giving names to my states. And so it goes on beyond this, and, I have all the rest of my states in there. What are those other parameters going to be used for?
It's for the 7 segments.
Yeah, the 7-segment display that I have is 8 segments. Right? And so that's just, again, just so that I have it in there. And then I have this initial begin, and I realized that I'm never going to change which display I'm using for my what floor I'm on. So I don't need to set that every time. I can just say mine has it so that I always have it on display 0. You can use any of the 4. So those of you who are listening and want to make it slightly different, you can have 1110, or you could have 1011, or you could have the 0 in any of the spots. And then I just set to initially, I'm going to be at floor 1 arrive. I just made that where I'm going to start. There's no particular reason for it.
Is that also going to be reset by chance? Is 0, 0, 0, 0?
I think so.
I would.
Actually, I don't really have a reset. Did I not save? Are you kidding me?
You.
Oh no!
What?
You don't include your reset.
What happened? Is it in the project summary? What happened?
Oh, the code isn't there. I don't know.
The code is not there.
Been there.
Honestly, yeah.
I was doing work
What happened?
and my save schedule got deleted.
Oh, that's.
Is there another tab of
I would be so mad.
No, what happened is Vivedo. I was in between classes, and I was working on this, and I had it all nice. My computer was low on battery, but Greek started. We don't use the computers. We don't have ancient Greek computers.
Oh.
Yeah, I mean, I kind of do. I can.
Yeah,
The
that
advocates.
Oh,
Well,
you're right, you're right.
Hey, that's one for you. Take that to trivia.
Shouldn't be speaking Greek now.
Oh, it's not gonna, Vivedo. It's not gonna get me all the, it's just some of them. It doesn't do accents. Okay,
Well, that's good.
yeah, that's great.
My physics
What
homework.
does that say?
Anthropos means human, as in anthropology. Okay, so my always block, my code is not here.
Should do Christos Anesti because it's Orthodox Easter.
Ah, yes. Let's see. What is it?
Christos Anesti.
Oh, okay. Probably in epsilon.
That looks right.
Yep,
Yeah, that looks right.
yep. Christos Anesti. That says Christ is here. Yeah.
Oh, okay.
Um, okay. Let me turn back to English. Okay.
Short Greek
All right.
break.
This is not what I was expecting. Okay, so always at, and this one would be current state and switch. And I also added, what I added was, because I'm putting in that, oh yeah, and it didn't change this either. So I didn't save at some point. I changed, for those of you who are going with what I did before, I realized that I didn't need 2 floor 2 intermediate things, and I just had floor 2 transition. But there's nothing wrong with having going up and going down. 4B 0, 0, 1, 0.
So, whenever you have don't cares in the parameters.
I'm getting there.
Oh.
I don't have them in the parameters. I'll have them in the case statements.
Okay.
The parameters have to be fully specified.
You don't have to get every single one, though, do you?
No, not in the parameters.
Okay.
Now, I put in an error state, and the reason I'm putting in the error state is that's what I'm going to have my default go to, so that if it shouldn't ever get to the default, but if it ever gets to the default, then I want to know that that's what it did, so that's why I called it error. So I have that error state in there as well. So always at current state and switch, and then you'll have, this doesn't need to be case Z because this one won't have any don't cares in it. So this will be always at, or in case current state, and you'll have all of your possible states. You'll have floor 1 arrive. Now, floor 1 arrive is actually easy because it doesn't have a separate case. It's always just going to be next state becomes equal to floor 1, what did I call it? Open, it's not up here. I think it's at the end of my list. Yeah, floor 1 open. Floor 1 open. So I have that. But for most of them, we'll have a case statement. So let's do the one that we did together, which was floor 2 rest. So floor 2 rest, we're going to have case, and I'm going to need to put a Z in it because we'll have don't cares. And it's going to be based on our switches. And somebody tell me what, because we wrote them down just a minute ago. We had, was it to stay where we were was X 000, right?
Yeah.
So next state becomes equal to floor 2 rest.
Why would that as case Z?
Because I have learned from trial and error that when you use don't cares, the case, it won't give you an error if you use just plain case, but it doesn't work right. So if you use case Z with don't cares. So the Z actually means that it actually means that you might have some things in here that are not determined.
Okay.
So
And that it all like the Vito already knows that, like
yes.
immediately. Okay, cool.
Yeah.
I didn't know if you had to like define that
No.
somewhere.
Nope. Nope. Okay, what else did we say earlier for floor 2? What else?
We said XX1X is open. It opens the door.
Yeah.
That's floor 2 arrive, right?
Yeah.
Okay, what else did we have?
000. Oh, we have an overlap. No, we don't. Sorry. XX01. That is 1 arrive. Or 1 arrive. Then we have X100, which is 3 alive. 4 3 arrive. Alright, blah. Dude, I can't talk. That's it.
Okay, so
Everything.
so now I have default is I could have it be anything, but I want it to be, I want to know if it goes here because it's not supposed to go here.
So, I know we said that it would prioritize 4-1 if we did.
Yes.
Okay, never mind. I saw it.
You see it?
Yeah.
Okay, so I'm going to do something like this for each of my states. So I'll have floor 1 arrive, I'll have floor 1 open, I'll have floor 1 rest, I'll have floor 2 arrive, I'll have floor 2 open, here I have floor 2 rest, and then after this one, I'd have floor 2, what I call transition.
Let's transition.
That's if you're on your way from floor 1 to floor 3, but you're not stopping at 2. You have to go through 2, but when you're on, if I'm going to 2, I go to floor 2 arrive and I open the door. And so floor 2 arrive, its output has the LED door open.
Can I have this? Do you have to have that? Because I would just make it to where if you're going up.
No, you can, I mean, from the way
Yeah.
we did it, it's cause like it says that, it's cause of the statement it says about the clock cycle.
Uh-huh.
Where it's like you need to have that
Oh.
clock cycle
Okay.
to like transition from one state, or one floor to another.
Sorry, I'm asking a lot of questions.
No, it's fine.
No, that's fine. It's not really fine because I told you to watch the video first. Yeah, I was very specific about that in my email.
You did?
What's that?
I'm sorry.
No, that's all right. So,
Alright.
so the difference for me for floor 2 transition and floor 2 rest had to do with the hold button and how we treated the hold button. But it's not necessary. you could have it go from floor 1 to floor 2 rest, and then if the switch is not set, that it would just continue on to floor 3. You don't have you don't that it, depending on how you set your state diagram, you don't have to have it. But the clock does say you can only go one clock cycle gets you to the next floor. And then after I do, I'll just go ahead and fill in it because the others are just floor 3. I don't think
You go from 1 to 3, they want to see like 1, 2, 3.
that has happened before, that they do want to see that. And so I know that. And then I'm going to have default next state is the error state, because I don't expect that I would ever be there. And then I have to have on this one, on each of these, I have to have an end case. And so notice I have a case, and within most of these, I'll have another case. So most of these are going to look like this. Let's fill in another one, just to make sure we got the idea. Let's figure out what we would do from floor 1 open. Floor 1 open. So don't pay any attention to any of these, because these aren't correct. Actually, I don't have time to do this. So floor 1 open. Yeah, I don't have time to do that. I did have it all done, but no, I lost it. Okay, and then at the end of this, I will have an end case. So I have a big outside case statement that has all of the floors, all of the states, and within each of these states, I will have another case statement based on the switches. And then I will have another always block that anytime I change what the next state is going to be, so it's computing the next state, I'm going to figure out what my next outputs are going to be. And this one is going to be easy. So this one is going to be, you'll have all of your states. And you'll have to have a begin and an end, because you'll have two things in here. You'll have next output. Oh, I just realized I needed something else up here. I need LED, next LED. Okay, so next output is going to equal 1. Next LED is going to equal 1. End. I know. And then what would I have? Floor 1 open. Oh no, yeah, that's right. Floor open. Floor 1 open. What am I going to have?
Floor 1 arrive. Wait, no. Sorry. No,
It's going to have exactly the same outputs as floor 1 begin, right?
Okay, so this is to define the segment,
The 7-segment display.
if the LED is on or not, or where exactly is that next LED?
This is going to say whether the LED for the door open is on or not.
Okay.
So the next one I would have, which would be floor one rest, would look like this. With a 0. And then you'll have your, and then you'll have each of those, and you'll have your default, and just pick something for that, and then you'll have your last always block. Always at the positive edge of the clock. Begin. Current state becomes equal to next state. What else do I need?
Next state is, no. I don't know. Segment is next, is current state, next state, oh.
Alpha.
Next LED. Yeah, I got that one. Pretty cool.
And that's it. So there's not, it's all in your state diagram. So it's all in your state diagram, and then you'll need to test it. And you'll want to do that before lab day, if possible. And I have the boards here, so you can just, I will be here Monday. Are you doing your demos on Tuesday? Next Tuesday? Next Tuesday. So I'm gonna be around Monday afternoon. Like I won't do other stuff. I'll be around like from this time on. Usually end up staying pretty late. Hopefully not this year, because hopefully people will believe me and do finite state machines and not do a whole lot of programming. And if they do a whole lot of programming, that they'll get it right. But we'll see. All right, that's it.
Do you have office hours tomorrow?
Yeah, 1:30.
Dang, it's like the only time I have class.
Oh, I can be at another time.